Now we're at a point where they're not going to tell you what function you're looking at, but you need to identify that yourself. So you have to apply all the knowledge that you have. We need to build your confidence in this section. And if you haven't done so already, grab a copy to the link of the workbook in the description below. Let's get going. Show that the following two lines, so we are dealing with lines, and we need to show that they are parallel. Okay, so there's a bunch of things that needs to come up in your mind. Great tense, when you hear straight line, well, you need to think, well, I know my standard form, y is equal to mx plus c. I know that that is my y-intercept, and I know that that is my gradient. Okay, so that needs to come to your mind. Then what also definitely needs to come to mind is parallel. When are lines parallel? How do we know when lines are parallel? It's when the gradient of the one line is equal to the gradient of the second line. So parallel lines share the same gradient. So that is all knowledge that we need to be able to tackle this question. So if we look at that first straight line, it is in standard form. When it is in standard form, we know that that will be the gradient. So the gradient for this line is equal to 2. If we look at the second line that we were given, that one is not in standard form. So if it's not in standard form, then we can't read off the gradient just yet. We have to do some manipulation of that equation to go put it in standard form. 2y is equal to, we just take this one over. So far, so good. And now to get y by itself, we need to divide by 2 on both sides. So that means that I'm going to divide this side by 2, and then I'm going to divide that by 2, and I am going to divide that by 2. And now it is in standard form. And there is our gradient. Our m is 2 as well. So what did they want us to show? They wanted us to show that the two lines are parallel. So then I would end off by just saying, therefore, the lines are parallel. Perfect. Second question. Use the graph in the diagram below to answer the following questions. Okay, before we even look at the questions, let's just quickly study the diagram together. We can see that it's a straight line. So what needs to come to mind? Y is equal to mx plus c. Then we say, okay, well, we know that the c is the y-intercept, and we got given it there. So we know that the c value will be equal to -1. That's knowledge that we need to have. Then we also got given a random point that's on the line. And there we've got an interesting point where we've got the y value, but we don't have the x value. They just gave the x value to us as t. So that is an unknown x value. And great tense, if I look at this, like if I see that x is 2 over there, so then surely if we can estimate over there, so it must be bigger than 2. So it must be like 2.5, 3, 4, 5, whatever. Okay, I don't think there's anything else. We were not given the x-intercept. We can see that it will be a positive gradient. We can definitely see that m must be bigger than 0. It must be positive because the graph is increasing. Okay, so now we've investigated that diagram properly. Let's see the questions that they want us to answer. For 2.1, it says, give the coordinates of the y-intercept. Well, we've already done that thinking where we identified the y-intercept. Do make sure that you don't just write down it's -1. They want the coordinate of the y-intercept. So, yeah, you want to get that mark for doing that properly. And there is our y-intercept. Okay, let's look at the second question. Calculate the gradient. Okay, we can do that. How do you calculate the gradient? You need 2 points on a line to be able to calculate the gradient. And then we're going to use our gradient formula, the change in y over the change in x. So it's not going to help me to use the point that includes a t because that's missing information. We need to use the 2 points where we do have the information. So we are going to use the point 2 and 3, and then the point 0 and -1, the y-intercept. So if I get the change in my two y values, it will be -1 and I take away 3, and then 0 and I take away 2. If we simplify that, that would be -4 over a -2. And if we divide those two, it would give us a positive, and it would be +2. So our gradient is 2. That's it. There's one more question there. Oh, there's 2 more questions. Oh, there's 3 more. Write the equation of the graph in the form, well, that just represents our y, right? They just labeled this one f of x. So y is equal to mx plus c. We can do that too because we have all the information that we need. We already found our c value and we just found our m. So there is our m and there is our c. There's my m, there's my c. There's my m that we calculated, and there is our y-intercept that we already found. All right, 2.4. What is the value of t? What is the value of t? So t is a missing x value that we have. That's part of a point. But what's great is the fact that we have that y value. And what we also need is the equation of the line, which we do have. We have got the equation of a line and we have the input value x. I'm lying. We've got the y. We've got the y of 5, and this is what we are looking for. That is the missing piece of information that we are looking for. Now, what is great, once we have the equation of a straight line, we can use that to find any output value if we've got the input value. Or the other way around, we can find any input value if we've got the output value. So in this case, I'm thinking of one thing and writing something else. So there is the equation of our line. What I'm going to do is I'm going to substitute that information in. So I'm going to plug into the place of y5. And then it will spit out the x value at that same coordinate for me. So if I take that over, now it's just equation knowledge, and then x is 3. So where my y is 5, my x is 3. So therefore, t must be 3. Remember that when we're doing functions, substitution is your friend. Last one, 2.5. Okay, so let me just quickly, before we look at that, it looks a lot worse than what it is. I'm just going to write down my equation over again that we've already found. Okay, and that is equation f. They made that equation f. It's just a notation, nothing funny. Let's see what it says. Find the value. So we need to actually come up with or find a value of this, of all of that. Now, that looks like a lot, but let's just break it up. So if we have 3, that means times. 3 times, and then f of 2. Well, surely that means in the place of f of x, wherever we see an x, we just need to put in a 2. So what is that going to look like? It's going to be 3 times and then into our f of x. Wherever we see an x, we are going to plug in a 2. So wherever I saw an x, I plugged in a 2. And we're going to calculate that so we can actually get the value of that. So that would be 3 times, 2 times 2 is 4, take away 1 is 3, so that would be 9. So the value of that is 9. Now let's do the other side. So that means 4 times f of -1. So same story. Wherever I see in my function an x, I'm going to plug in a -1. So it's going to be 4 times, and then into my function, wherever I see an x, I'm going to plug a -1. Just like that. Let's get that value. So it will be 4 times, well, 2 times -1 is -2, and if I take 1 more away, it will give us -3. And if I multiply that, it would give me a -12. All right, now let's put all of this together. We've got the value of the first part, and then we've also got the value of the second part of the sum, which is that one over there. But it says that it needs to be subtracted. So it looks like we've got, there's the first one, 9, and we are subtracting whatever the second part is, which is -12. So just make sure that they are being subtracted. And that gives us, what is that? Is that 21? Yeah, I believe so. So the value for that is 21. So just get comfortable with using the notation like that. It looks a lot worse than what it is.